Well, when you're doing this lab, right, you're going to be at the beginning here. You want to select intro so that you have the main page up. The first part of your lab asks you to just play with all the sliders and the tabs so you know how the variables change, right? So this talks about string length for a pendulum. This shows you how to change the mass. You can change gravity and friction if you want to. And over here on the left side is where we are looking at having a stopwatch and then including something known as period trace, which will show you um, the time it takes for one cycle to occur, which is something that we're going to be using during this lab. So the first thing is you want to describe what a cycle is, and I'm just going to kind of let this pendulum swing, but you can see the blue line that's being traced on there is representing one cycle, how a pendulum swings back and forth and back to the midline. That represents one cycle. And then if you had to describe this pendulum using amplitude, if there's no friction, the pendulum will swing back and forth to the maximum amplitude or the maximum distance away from equilibrium here, or this midline. So amplitude is the angle away from the midline or equilibrium for this pendulum. So your goal in this lab is to go through and figure out how these different variables affect a pendulum. The first thing is you're going to be identifying period. And for this, you need to time 10 cycles or 10 back and forth motions. And then from there, we can do some calculations. So when you're doing this, right, make sure you are able to count and aren't being distracted. But every time a blue line appears, two cycles actually occur. So every new dark blue line that's made represents two cycles. So when I get the first one going here, I'll start my timer. Now, that was 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Oops, I stopped a little early, but you get the main point. This would be my time that I'm going to write into my data table under the oscillators and period, and then I'm going to run my trial again and do that two more times. So I have 3 total trials of 10 cycles and the time it takes for those 10 cycles to occur, and I plug those into my data table. I'll find the average and then divide by 10. So then I know the time it takes for just one cycle to occur, aka the period of a pendulum. So that's the first part of the lab. The next part of the lab is going to be going through and seeing how different variables affect the pendulum. So you're going to be looking at mass, you're going to be looking at amplitude, and you are going to be looking at string length. For all 3 of these, you're going to be going through and changing these variables according to what's in the data table. So the first thing is you want to set, we're going to be working on mass next, and it says to set the mass to 0.5 kilograms. So I did that over here on the side. And then everything else I'm going to keep relatively the same. So if I just hit, this reset button in the corner, I'm just going to leave everything else the same just to make sure I have things consistent every single time. And the only thing that I'm changing is my mass, right? I get to choose the amplitude or the angle that I'm going to use when I'm doing these trials. So I need to make sure that I'm doing the same release point. Same thing for part 1. So I'm going to just always use a 40-degree amplitude, okay? And again, I'm going to run 3 trials of 10 cycles and record that time. So I'm going to let it get going here for a moment here. And then I'll start timing. 1, 2, 3, 4, 5, 6, 7, 9, and 10. right? And so I'm going to record that. I'm going to do 2 more trials with the 0.5, and then I'm going to move on, and I'm going to change my mass to 1 kilogram. And so I said this into my other class. If you don't change friction, your times shouldn't change. So you should end up having kind of the same sort of trials if you're not changing friction. So that's kind of a cheat to getting through this lab a little bit quicker. Again, I'm going to start at 40 degrees, I said, so I'm keeping that the same. And then I release, and I'm going to, again, check my 10 cycles, right? There we go. Starting. Oops, I forgot to reset, so I got to redo that. Boom. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Boom. And I'm going to record that, do that 2 more times, and then go on to 1.5 for the mass. Okay. And then the next part is talking about going through and identifying how amplitude affects our pendulum. So I'm going to reset all those things so that it's back there. I'm going to relink those. And it says we're going to start with a 20-degree amplitude, and I'm going to keep my mass and string length the same. And so I'm going to work with a 20-degree amplitude to start and do the same thing. 1, right? 2, we get the point, so on and so forth until I get my 10, record it, and run a few more trials for 20 degrees, then move on to 30 degrees, run my 3 trials, and then move on to 40 degrees and run my 3 trials. Okay? So that would be amplitude, and then string length is my last one, where it's asking me to go through and show the differences of string length. So if I reset everything, my string length I'm starting with is 0.4. Gonna just keep my angle the same as I talked about before. I use using 40 degrees so I can see how that goes. And then I can start recording my 10 cycles again. And then once I get that, I'll put my data down and then move on to the 0.7 length and then do my 3 trials and then do the same thing for 1 meter. Okay, and then at the end, it's going to ask me about the relationship between all these variables, writing a summary of how each variable impacts period. And hopefully you notice that there are only some specific variables, not all of them are going to be impacting the time it takes for 1 cycle to occur or the period of a pendulum. Oh my God.